Good morning, everybody. Firstly, I would like to thank the organizers for inviting me to give this presentation here today. Yes. In daily clinical practice, we are constantly measuring. We are doing tests, we are measuring and assigning numbers, numeric values to, for example, strength in the Daniel scale, for example, or the supination resistance test, or we are measuring range of motion. We are assigning numbers to articular motion. And because we need to know the normal limits of some things, the normal limits of strength, of motion, of etc., etc. When we are doing physical examination of the foot, as podiatrists, we have techniques and procedures to quantify the range of motion of the main joints of the foot: the ankle foot, the subtalar joint, the mid-tarsal joint, the first metatarsophalangeal joint. But what about the first ray? Ruth and colleagues suggested that we had to move the first metatarsal head toward dorsiflexion and then toward plantar flexion, and compared both movements. And they proposed that the normal limits were 5 millimeters of dorsiflexion and 5 millimeters of plantar flexion. Unfortunately, manual examination lacks sufficient diagnostic accuracy. How can we quantify the first range of motion? If we have a look at the literature, we find some authors that over the years have developed different instruments. For example, Rogers and Kavanagh developed the first measuring device in 1986. Clough and colleagues also developed this frame attached to an ankle-foot orthosis. The Clough and colleagues device is also a complex instrument attached to an ankle-foot orthosis. And these instruments are too sophisticated maybe to make a quick test in daily clinical practice, okay? Although Clough's and Glassow's devices have demonstrated good validity and good reliability. Also, we have other instruments like Kim's, like Dr. Whitney's, or like Dr. Michaud's instruments that are smaller and are lighter and easier to use, but their validity and reliability is, unfortunately, have not been demonstrated yet. So, we have valid and reliable instruments, but they are too big and complicated, and also they are not available for buying, for example, and they are not good for clinical practice, okay? On the other hand, we have simpler and easier devices with that full validity and reliability, so they are not good for research. In this point, we identified a knowledge gap. Where's the knowledge gap? Can you change, please? Yes, knowledge gap. And we started to make questions. The first question was, well, how can we measure the range of motion of the first ray in a quick and easy and simple way? Due to the orientation of the articular axis of the first ray, it moves in the sagittal and frontal plane at the same time. So an instrument to measure the first ray mobility had to reflect this characteristic. The response to this first question, can you change, please? Yeah. No. Okay. The response was a new device that was patented with two arms with a curvature that these two arms slide smoothly one against the other and draw this curvature that represents the mobility of the first ray in the sagittal and frontal plane. Okay? Can you change, please? Well, the next question arises soon because we needed to know how is the real movement of the first ray? How must this curvature be? Can we use whatever? Please. Okay. No, before, please. Okay. So we did a study we studied anterior-posterior radiographs in 3 positions, with first ray in neutral position, with first ray maximally dorsiflexed, and with first ray maximally plantar flexed. And we calculate the movement in the sagittal plane, studying the distance between the distal end of the medial malleolus to the intersesamoid crest, and we studied the movement in the frontal plane with an angle formed by the ground and a line connecting the intersesamoid crest and the superomedial tubercle of the first metatarsal head. This angle, please change, this angle increased with dorsiflexion and supination and decreased with plantar flexion and pronation. Change, please. So the response to question 2 was that, well, more or less, Ruth and colleagues and us have the same results. They show them clinically, and we have obtained them by means of research. The first ray more or less moved 6 millimeters of dorsiflexion and 6 millimeters of plantar flexion, a little more dorsiflexion than plantar flexion in the sagittal plane, and it moves, well, near 3 degrees of supination with dorsal flexion and more or less 3 degrees of pronation with plantar flexion. That is 0.45 degrees of movement in frontal plane for every 1 millimeter of movement in sagittal plane. Okay? Please. So, question 1 and question 2 led us to question 3. We manufacture a new device to quantify in an easy way the mobility of the first ray, but is this new device valid and reliable? We did a study in which compared the mobility of the first ray in normal and hallux valgus feet obtained on the one hand with the new device and on the other hand with radiographs. Change, please. And several statistical analysis gave us good results. For example, making comparisons with bootstrapping reported good p-values, which means that the variables showed different behavior depending on whether they belong to hallux valgus foot or normal feet. So they were included in the next statistical analysis, cluster analysis, that reported a coefficient, silhouette measure of cohesion and separation coefficient higher than 0.5, which means that these variables, dorsiflexion, plantar flexion, and total movement, have a good classification power. That means that the cluster analysis had good quality. Change, please. Also, another one. Also, Bland-Altman graph showed good agreement between the both methods, radiographs and manually. And finally, the rock analysis give us also good results. This means that the new device seems to be valid, okay? Another one, please. In order to study the intra and inter-observer reliability, two examiners did two measurements in 2 different days, separated by 10 to 30 days, both measurements. Can you change, please? Another one? Okay. And the intra-class correlation coefficient was in all cases higher than 0.75, which means that good reliability as well. So the response to question 3, is this new device valid and reliable? Yes, it is. But when used well, what mean used well? We have to put the vertical part of the higher piece on the neck of the second metatarsal. Then we have to hold the first metatarsal head and bring it to the neutral position, to the same plane of the lesser metatarsal heads. And from here, we have to move it to the maximally dorsiflexed position during supination, then bring it again to the neutral position and move it to the maximally plantar flex position during pronation. This is the correct way to use this instrument to get valid and reliable results. Please. Another one? Okay. Other questions have arisen since then. For example, is the mobility of the first ray different in normal feet when we compare to hallux valgus feet? Well, the same study we used to validate the instrument gave us these results. We observed that total range of motion was similar between both groups. However, hallux valgus feet showed more dorsiflexion than normal feet. In many cases, hallux valgus initiates with the first ray with an increased dorsal flexion. This increased dorsal flexion is accompanied with an increased supination of the first metatarsal. In a moment, in the second half of this tense phase of gait, in a moment when the intrinsic muscles are trying to fix the hallux to the ground. And we have to remember that the sesamoids are partially encapsulated by this tendon of these muscles, okay? So, in this unstable situation, please, again, this increased movement of the first metatarsal is gradually making an erosion of the intersesamoid crest that leads it to gradually disappear. We can see these images, one of the normal foot up and one of hallux valgus foot without intersesamoid crest. Again, please. And what's next? In this situation, when flexor hallucis longus contracts, an abductor, again please, an abductor moment of the hallux appears that contributes to, again, increased lateral deviation of the hallux and medial deviation of the first metatarsal because of the displacement of the sesamoid with respect to the first metatarsal. Again, please. And the final result is known by all of us, isn't it? And we make another question, similar question, but with hallux limiters. And we did another study and observed that, again, the total range of motion was similar between both groups, normal feet and hallux limitus feet, but hallux limitus feet showed more dorsal flexion and less plantar flexion than normal feet. Please. First ray plantar flexion is a requirement to achieve the normal hallux dorsal flexion, okay? Without first ray plantar flexion, hallux is able to achieve only maybe 20 to 30 degrees of dorsal flexion. Again, please. The reason is why is that when we have a first ray dorsiflexed, please, the center of rotation of the first metatarsophalangeal joint moves downward and forward. And in this situation, when hallux is going to dorsiflex, the dorsal half of the proximal phalanx base impacts with the dorsal half of the first metatarsal head. And this leads to osteophyte and bone proliferation, giving rise to, the next please, giving rise to the typical image of a hallux limitus or hallux rigidus of bone proliferation, especially, another one please, on the dorsal half of the first metatarsal head and the dorsal half of the first metatarsophalangeal joint. Another one. We have more questions, but we have no time enough to respond everything, and we are working on it. For example, okay. How is the mobility of the first ray in hallux valgus feet after and, before and after a hallux valgus surgery? We are working on it. Another one, please. How can we improve the first ray mobility using an exercise program to strengthen the peroneus longus muscle? We are working on it as well. And the last one, what is the normal mobility of the first ray, but using the new measuring device? We are also working on it. But the main question of this work is, no? Oh, yes, I was confused. Okay, to summarize, we can remind our questions and our responses quickly. How can we measure the range of motion of the first ray in a quick, easy, and simple way? Please, with the new measuring device. Another one, please. How exactly is the motion of the first ray? How is the curvature? More or less 0.45 degrees in frontal plane for every millimeter of movement in sagittal plane. Another one, please. Is the new device valid and reliable? Yes, it is, but we have to use it well. Another one, please. Is the mobility of the first ray different in normal feet when compared to hallux valgus feet? Another one. Total range of motion is similar, but hallux valgus shows more dorsiflexion. And the last one, what about hallux limitus feet compared to normal feet? Again, similar total range of motion, but hallux valgus feet show more dorsal flexion and less plantar flexion. And the great question of this work is, have we got a quick, easy, valid, reliable, etc., way to measure the first ray mobility for clinical and research activities? And the response is yes, we have. Thank you very much for your attention.